Hey everybody, Manane here. Today I'm going to talk about how CuratX can help you secure your AI-powered coding environments. We'll start with a quick background of the important security issues with these AI-powered coding environments. Then I'll show you how we're helping teams maintain the speed of these AI coding platforms while solving a lot of these security problems. So as we see, this graph on the left right here, we're seeing a fundamental paradigm shift throughout the years in how software is being built. Starting in January 2023, we kind of have the introduction of GitHub Copilot and how this really kicked off, kind of like this market of AI-assisted coding. But if we, start taking a look at, 2024 and 2025, we see kind of, the introduction of cool tools like Cursor and Cloud Code, which have, more of a control in the workspace, really start exploding in popularity. And as we start, see getting closer to the modern day, we see that the annual recurring revenue of a lot of these companies and tools is racing towards the $1 billion mark. So the question presents, why are enterprises spending money on these tools? Well, there are four main reasons that they're doing so. The first is the obvious productivity increases. Really, engineers are able to spend a lot less time on the boilerplate, on writing boilerplate code, and really more time on actually solving the problems. Additionally, there's also a certain level of quality and consistency with a lot of these coding agents. Specifically, a lot of these agents can enforce specific design patterns and catch a lot of simple but important errors very early in the development cycle. In addition to that, there's also the knowledge leverage. So AI agents are really able to compress a lot of the information within the code base into an understandable manner and distribute that knowledge to members of the team or people who are working on the code base. And finally is the faster experimentation. So teams can really experiment with different ideas and generate proof of concepts in very, very, very quickly. So these are obviously very important benefits, and that's the reason why that this market has become so lucrative. However, they're not infallible. And so this brings us to kind of the other side of the coin with regards to the security issues with these AI-powered coding environments. So specifically, I see two main kind of categories of security issues for these AI-powered coding environments. So on the left, we have issues in relation to the AI-powered coding environment itself, specifically the actual agents that are orchestrating a lot of the development. So as I've touched upon, we've really advanced throughout the past couple of years in terms of kind of like these AIs to coding environments. We've went from kind of like these autocompletes to these agents that can really interact with your workspace at sort of a very, very low level, run, a lot of these terminal commands and modify these files. And just, as I mentioned, just really experiment and really work with the workspace at this low level. So as you can imagine, this kind of introduces a ton of operational risks, and it's really not hard to see why. If an agent has, privileges to really build, test, and debug, especially at the shell level, there is a potential that it can really be manipulated into running malicious commands on a developer's machine. And I will get into detail on how this can materialize. And on the right, we see that we have issues in relation to the generated code. And, a lot of models really have the tendency to kind of generate and really optimize for the plausible output, but not considering that it also needs to be the secure output as well. So they have the tendency to hallucinate a lot of packages, use a lot of insecure patterns. A common case of kind of insecure patterns is the golden hammer anti-pattern, where the generated code by an agent tends to kind of use a one-size-fits-all approach for solving a problem. In addition to these, they also have the agents also have the tendency to invent APIs that don't exactly exist. So teams might ship faster with a lot of this code, and it will definitely be working, but they also might be accelerating a lot of vulnerabilities into production. So now that we've framed sort of the problem with these AI coding environments, let's see how this is materializing within the current foundational models. So this is a securities benchmark called Backbench that sort of benchmarks how well a model is able to write code that lacks security vulnerabilities. So specifically, I want to highlight two major aspects of this graph. The first is the correct and secure rate of each of the different models. And I would also like to highlight the correct and insecure rate of all of these different models. So specifically, if we take a look at even like the best performing model, we see that the correct and secure rate is no more than 37%. And this is concerningly low. I mean, even like contemporary models like GPT-5 and Claude 4 Sonnet only reach a rate of only about 50%. So this really shows that even the best models are still insecure a significant portion of the time. And really, what this shows is that this really shows that there's an important need for kind of this layer, the security layer for these coding agents that incorporate a lot of these security policies into and really, imbue a lot of these agents with these important security considerations. So now that we've seen this on the benchmark level, let's see how this looks like in a real workflow. So we have three different examples that I'd really like to highlight. The first is, kind of like this silent code execution. So really kind of the problem is that, especially this is kind of, an issue with Cursor, but Cursor often defaults to kind of trusting the workspace a lot more than the standard VS Code. And, an attacker can, really have kind of a task.json file filled with malicious commands in a lot of these public repositories. So, a developer can bring, this repository into their own environment, and, there wouldn't be, too many checks. And then the agent, is, looking through the code base and, seeing, kind of like this task.json file, and it will run it, willy-nilly. And the problem is that when it runs this task.json files, the commands listed and the code listed within this task.json files will run a lot of malicious tasks. And it could do things like export AWS keys or install a reverse shell. And this could obviously lead to a lot of vulnerabilities. So the second aspect that I like to talk about is kind of like this vibe coding or vibe scamming. So a lot of these AI-assisted coding environments really are able to generate full-stack apps from just a simple prompt. And the problem is that a lot of attackers are actually utilizing this in a whole host of unethical ways. One of the common examples is kind of like these phishing sites that get this information, kind of like these credential harvesting flows. The problem is that a lot of these agents really lack a lot of the strong guardrails to really refuse building kind of like this malicious infrastructure. And the final category I'd like to talk about is the compromised system prompts. So attackers can sort of upload a lot of these rule files, these quote unquote optimized rule files, onto different repositories, and they would be available on like a lot of these public catalogs. And then a developer would, bring this into their, coding environment and, just use it. The problem is that, while on the surface it might be looking like they're improving the agent's behavior, in reality, there's a lot of hidden instructions that, could cause a lot of potential backdoors within the code base that the agent is working with. So the key takeaway to really take is that the threat isn't just from the insecure code and a lot of these vulnerable patterns. It's also the fact that the agent itself can really be tricked into performing a lot of these dangerous actions. Um, and this really and we'll really see how dangerous this gets when the agents are allowed to run a lot of these commands directly. So this is a kind of a bug report filed against Claude Code. So a user, is utilizing Claude Code, and essentially what the agent tried to do is it it essentially executed this recursive delete command, and it pretty much wiped the his this user's home directory. And because this was an agentic tool with sufficient enough permissions, it executed the command and it just wiped out this home directory. And it really shows kind of like the dangers of really relying on a lot of these agents. Again, like at its core, the models that are powering these agents are stochastic in nature. They aren't consistent all the time. So really having a system that has this level of randomness and granting it kind of like this root level access without some level of governance is, well, I mean, it's pretty obvious. It's pretty just gambling with your infrastructure. So now that we've seen kind of like this case, I'd also like to talk about the other aspect, which is kind of like the issues with the generated code. And specifically, I wanted to highlight one example of this, which is hallucinations. So specifically here, this is kind of like a graph. And essentially what this is saying, how to interpret this is that this is a set of different prompts. And obviously these are a set of models. And essentially for each prompt, they're trying to see kind of like the consistency of predicting the same package names over and over and over again. And if we take a look at a lot of these, we see that this shows that for different questions, a lot of the models are hallucinating a lot of the same fake package names. And this is a vector that can be exploited because the hallucinations have this level of reliability in terms of prediction. Attackers can find these fake names and weaponize these names and really exploit and really cause a lot of issues. And we can see that, and we will see that this is a massive problem, as this leads directly into the slop squatting attack. So this is pretty much exactly what I just described, the slop squatting attack. So essentially, here we have kind of like a developer kind of asking kind of like these kind of like asking this model to kind of develop kind of like this web service for ingesting data and doing kind of like this detailed logging. And they've obviously specified the functional requirements. I'd like to also really touch upon kind of like the open telemetry. So essentially, the developers, they have these requirements, and the model is suggesting kind of a lot of these different packages. I'd like to touch upon the open telemetry, because if you know anything about open telemetry, this is actually not the correct package name. It's actually OpenTelemetry API or OpenTelemetry SDK. Now, this is kind of like a simple mismatch, but this, as I said, could lead to this vulnerability. Because what if this package is registered with a lot of malicious code? Well, the developer will just install either through pip install or npm install, and they would silently kind of install a lot of this malicious code instead of the library that they want that actually contains the functionality. So it's not just, about just, the slop squatting attack. Hallucinations are also an important aspect when it comes to kind of an aspect that I touched upon, in the beginning of the presentation, which is kind of this knowledge leverage. Um, in particular, kind of this kind of like this knowledge leverage, this kind of like understanding the code base. So over here we see that this developer is asking Copilot to compare two different branches, right? You have a current branch and you want to compare it to the main branch. Common use case, right? So and they want them to summarize the changes. So problem is instead of sticking to the diff, the actual agent started fabricating a lot of class names that never actually existed in the repository. So the impact of this is obviously very severe. As he's kind of touching upon, there's it slips through the cracks, and it will generate kind of like this fictional context. And the result of this is that an engineer can start building on this fictional context, waste hours debugging non-issues, and in the rush of things potentially write features that may be based on a completely wrong understanding of the system, which could potentially lead to further vulnerabilities in the system that they're trying to work with. So all of these aspects, when we combine all these aspects, it paints a very simple picture. The security in favor of speed, the security aspects aren't, being considered when generating a lot of this code. So how do we get both the speed as well as the speed and the effectiveness of a lot of these benefits, while also while also not incorporating a lot of the significant security and technical debt? So this is where we come in. So we don't want to reject the tools entirely. We want to essentially shift the tools such that they can work within our context. And so the problem comes from the fact that it's really difficult and really time consuming to really disseminate a lot of important domain specific policies and company specific policies into a form that can be integrated easily into your environment. And so CuratX provides this middleman to really curate a lot of these rule files based on your domain-specific policies like OWASP or CWE or CIS, and the company-specific policies into kind of like these MD configuration and these rule files that can be integrated within your coding environments. So really, when an engineer is using a Cloud Cursor Cloud code, the agents are able to produce code that is compliant with your security policies. So you won't have to worry about the coding agent not following your authentication and authorization patterns because, well, we ensure that the rule files will explicitly mention how this is an important consideration to have in your code base. And really, we've tested this with a specific client, and we're starting to see the results. So they're able to ensure that their secure coding is up by 32%, as well as they're able to get, the productivity enhancements by up to 21%, because again, we also are able to minimize a lot of this technical debt. And this also provides a lot of other benefits because we're able to enhance the documentation quality by 20% because of how we define the rule files and these configurations. And we're able to minimize the code review time by 30% because we're able to minimize a lot of this technical debt. So really it stops being, security and speed stop being a trade-off and start being two that are both, boosted by these coding environments. So I'd like to thank everyone for watching this video. If your team is interested in, adopting coding tools and you really want to incorporate the speed and maintain a lot of the security policies, then we have two venues. We are making a lot of open source, we're open sourcing a lot of these general rule files and config files in the CuratX security repository that is public right now. We'll be having a lot of these in the next couple of days. We're also, additionally, you can contact myself or Omkar if you're interested in really, talking about your current setup and identifying where kind of like the biggest risks are. So yeah, please reach out to us, and we'd love to work with you to solve this problem of AI